Hello guys, this is Mr. Minai. I want to share about my wonderful electronic circuits called Practical Applications of the Voltage Divider. These circuits are very fundamental for all the electronics beginners, and these circuits are also important for electronics projects. I will show you this with my circuit diagrams and my practical work. And this so let's see my circuit diagrams first. Here you see this is my circuit diagram. This power supply of the voltage of battery. This the resistance of the first resistor R1. This the resistance of the second resistor R2. This the potential difference across the first resistor R1 and this the potential difference across the second resistor R2. As you see, saying the two resistors are connected in series, equal amounts of current will pass through these circuits. We call these circuits as maximum currents or IMAX. If we apply Kirchhoff's voltage laws to the whole circuits, we have this expression VB minus B1 minus B2 is equal to 0. If we solve for the resistance of the first, if we solve for the potential difference across the first resistor R1, we have B1 is equal to VB minus B2 obtained. If we apply Ohm's law to this resistor R1, we have B1 is equal to the product of Imax and R1. If we replace this formula in our expression, we have Imax R1 equal to BB minus B2 obtained. If we solve for resistance of the first resistor R1, we have R1 equal to VB minus B2 divided by Imax. And this so you understand this R1 resistance of the first resistor R1. This BB our power supply so the voltage of battery. This B2 potential difference across the second resistor R2. This Imax maximum current pass through this circuit. If we replace an LED in place of this second resistor R2, we have another equivalent circuit like this. Here you see this power supply of the voltage of battery, this resistance of the first resistor R1, this the potential difference across the first resistor R1, this LEDs and the potential difference across this LED is BLED. And this all this IF forwards current pass through this LED. And this so if we find the values of series resistor R1, we have R1 equal VB minus BLED divided by IF. This R1 potential this R1 the resistance of the first resistor R1. This PV potential difference power supplies or the voltage of battery. This BLED potential difference across the LED. This IF forwards current pass through LED. Okay, if you you understand. If we consider for 2 volts 20 milliwatt LED, when our supply voltage 12 volt, then we can easily calculate for the values of first resistor R1 like this. R1 is equal 12 volts minus 2 volts divided by 10 milliamp. This 10 milliamp, the ratios of powers to potential difference across LED. This 12 volt power supply, this 2 volt potential difference across LED. And this so R1 equal 12 volts minus 2 volts divided by 10 milliamp equal 1 kilo ohm. This calculation shows that if we use 1 kilo ohm resistor in series with an ideal LED, when our supply voltage 12 volt, the potential difference across that LED must be 2 volts and the maximum forward current across the circuit also be 10 milliamp. If we consider for 6 volt 60 milliwatt LED, when our supply voltage 12 volt, then we can easily calculate the values of first resistor R1 like this. R1 equal 12 volts minus 6 volts divided by 10 milliamp. This 12 volt power supply so the voltage of battery. This 6 volt potential difference across the LEDs or the voltage of LED. This 10 milliamp, the ratios of power so LEDs to its potential difference. And this so R1 equal 12 volts minus 6 volts divided by 10 milliamp equal 600 ohm. This calculation shows that if we use 600 ohm resistor and series with an ideal LED, when our supply voltage 12 volt, the potential difference across that LED must be 6 volt and the maximum forward current across the circuit may also be 10 milliamp. Okay, and this so you clearly understand. Now I will show you my practical work for only 2 volts 20 milliwatt LED with our supply voltage 12 volt. Here's my practical circuit. You see 12 volt my power supply, 1 kilo ohm resistor, 2 volts 20 milliwatts LEDs and voltmeter. This one you see positive terminal so the batteries and one side of 1 kilo ohm resistor are connected. This one you see another side of resistor, another side of LEDs and positive terminals of voltmeters are all together connected. This one you see cathode side of LED, negative terminals of voltmeters and the negative terminals of battery are all together connected. And this all you clearly understand. And let's see my practical work. Here you see this 1 kilo ohm resistor. Here you see this 12 volt 20 milliwatt my LED. Here you see my voltmeter. Here you see voltmeter ring 20 volt DC. Okay, and this so let's see my practical work. Here you see my LED lightning us. This 1 kilo ohm resistor, this 2 volt 20 milliwatts LED. Here you see my voltmeter reading 1.95 volt. 1.95 volt. Here you see a very important fact that you must clearly understand, and this circuit is thus the readings. So the readings values of this voltmeter is this voltmeters are emphasized the voltage divider values of this 1 kilo ohm resistor. Okay, a very important fact that you must clearly understand, and this circuit that the readings values of this voltmeter is in fact the voltage divider values of this 1 kilo ohm resistor. Okay, and this so you clearly understand. If you like me, please get me like and share to my channels and then subscribe to my channel. Thanks for watching.